Ever looked at the internet and just wondered, how does it all work? How do all these different apps and programs find each other to get things done? Well, today, we're going to pull back the curtain. We're turning a block of C++ code into a story, an adventure, really, that shows you exactly how programs connect and collaborate. And this is the central question, right? It's the big puzzle. You've got all these little specialized programs. Each one is an expert at one thing. They're all ready to work, but here's the catch. They have no idea the others even exist. So how do they team up to solve a problem that no single one of them can handle on its own? Let's find out. To make sense of all this, let's think of it like a small town filled with specialist workers. Everyone's got their own unique skill, but for any big project, they've got to find each other first. So let's go ahead and meet the key players in our little digital town. Okay, first up, we have the directory server. Think of this as the town librarian. Super smart, knows everything. It doesn't do any of the heavy lifting itself, but it keeps a master list of who does what. Then you've got the peers. These are our specialists, the individual programs, the workers. Each one is a genius at its own task, but they start out completely in the dark about who else is in town. And for our story today, here is our specific cast of characters. We've got 3 peers on the scene. Peer A, it's our addition expert, and you can see right in its code, its skill is sum. Then there's Peer B, who handles division. And finally, Peer C, our multiplication guru. Go ahead and remember who's who, because these roles are going to be absolutely crucial in a minute. So we have our town librarian, the directory, and our specialists. But how does the librarian even find out about them? You know you can't get hired for a job if nobody knows you exist. This first step is all about announcing your skills to the world. It's the registration process. The way they do this is actually pretty clever and surprisingly simple. It's all based on little text files. So a peer, let's say peer C, the multiplier, creates a file. Inside, it writes its name, C, its skill, MUL, and its personal mailing address, which is basically its inbox. Then it just drops that file into the directory's public inbox. The directory server is constantly watching that inbox, so when a new file pops up, it snags it, reads it, and adds that peer to its master list. Easy as that. And this is what that little file actually looks like. See, it's not some complicated code. It's just plain, simple text. The operation is register, the peer is C, the skill is mul, and here's the address where you can reach me. It's basically a digital business card. That's all it is. So once all 3 of our peers, A, B, and C, have dropped off their business cards, the directory server's internal address book, called GLB registry in the code, is totally up to date. It now has this perfect list. It knows peer A does addition, B does division, and C does multiplication, and it has the exact inbox address for every single one. The stage is officially set for some teamwork. All right, the whole system is primed and ready, so let's see it in action. Here comes our hero, Peer A, the addition specialist. It suddenly gets a task it has no idea how to do. Multiply 7 by 6. Peer A only knows how to add. So, what's it going to do? It does the only logical thing. It asks the one guy in town who knows everybody, the directory. And you're going to notice this process looks really familiar. It's almost the exact same as registration. Peer A creates another one of those simple text files. This time, it's a lookup request. It puts its own ID in there so the directory knows who's asking, and then it specifies the skill it needs, MUL. It drops that file into the same public inbox, and the directory server immediately starts scanning its master list looking for a match. And here it is, the lookup request itself. Again, it's just so simple and clean. The operation is lookup. The requester is peer ID A, and the skill I'm looking for is op_name mul. It's just a clear, direct question to our town librarian. Hey, can you find someone who can multiply for? And bingo, the directory finds a match. It immediately creates this response file. Now, this is the crucial part. It doesn't just shout the answer to the whole town. It places this file directly in an outbox folder that only Peer A is looking at. The response says, yep, I found one person for you. Their name is Peer C, and here is their direct, personal inbox address. Peer A now knows exactly who it needs to talk to. The introduction has been made. This, right here, is where the peer-to-peer magic really happens. The directory has played its part. It was the matchmaker. Now it steps back completely. With Peer C's address in hand, Peer A can reach out and talk to it directly to get the actual work done. So Peer A writes up one last file. But this one isn't for the directory. this is a task file. It spells out the service it needs, MUL, and gives it the two numbers to work on, 7 and 6. Then it places this file, and this is key, directly into Peer C's personal inbox folder. This is true peer-to-peer stuff right here. Peer C is always keeping an eye on its own inbox, so it finds the task file right away. It does the math, 7 times 6 is 42, of course, and it creates a result file. It then sends this answer right back to Peer A's outbox. The job's done, the request is fulfilled, and the answer has been delivered. And just like that, success. Peer A, a program that only knows how to add, has just solved a multiplication problem. It didn't need to learn a new skill, it just needed to know how to ask for help. And that is the real power of a distributed, collaborative system like this one. Okay, so we followed this really neat little story of files and folders. But let's zoom out. What's the big picture here? Why is this kind of architecture so important? Well, it turns out this pattern is a fundamental, a really core concept in pretty much all modern software. You know that whole dance we just watched, the registration, the lookup, the direct connection? That entire process has a name. It's called service discovery, and it is the engine that allows systems to be so dynamic. It lets programs find each other on the fly, automatically, without anyone having to hard-code their addresses in advance. And this design gives us some incredible advantages. First, decoupling. Peer A never had to know a thing about Peer C. It just needed to know about the directory. Second, direct communication. As soon as the introduction was made, the directory got out of the way, which is great because it prevents a bottleneck. And finally, scalability. What if you need a new skill like subtraction? No problem. You just spin up a Peer D, have it register, and bam, the entire system instantly knows how to use it. So this whole elegant system, this matchmaking service, works absolutely perfectly as long as our librarian, the directory server, is on the job. But that brings us to one last pretty important question. What happens if that central directory goes down? If there's no one there to make the introductions, how do our specialists find each other then? Well, that's a story for another time.